5, for instance, the instructions for like 1 through 9 odd are solve these right triangles. And so for number 5, you have A equals 6, B equals 12. If you notice, if you look at all of these things here, they're all referring to these triangles down here at the bottom, and they kind of just draw one generic triangle, and they label the sides A, B, C, and then across from side A will be angle A, across from side B will be angle B, and across from side C will be angle C. So they're giving you different pieces of information. Bless you, bless you. If you remember in trig, if you have an angle and a side, you can figure out the whole triangle. That's what SOHCAHTOA did for us in geometry. It allows us to fill it all out. Now on number 5 here, they're actually giving us the 2 legs of the triangle. So what do you think we're going to start off by doing here? Yeah, we go find the third. If we got 2, might as well go find the third. This 6 and 12, let's see if there's anything hiding in it. Those are both divisible by 3, aren't they? So 6 divided by 3 would be 2, 12 divided by 3 would be 4. I was hoping it was a 3, 4, 5. It's not, unfortunately. So we got to do the Pythagorean theorem. 6 squared plus 12 squared would be what? C squared. So 36 and 144 is C squared. That's 180, I think. And so square root of 180, let's go ahead and write it simplified. Let's see, 36 goes into 180. How many times? 5, I think. That would be the quickest way to reduce that, because the square root of 36 is 6, so it would be 6. Square roots of 5 would be our third side. So let me write it over here. I'll write it in red to show that we found it. Those were supposed to be multiply, but I kept touching it, and it has lots of little dots in there. Okay. Now they want us to solve the right triangle, which means they want us to find everything in it that's missing. We found side C, so we might write it down. Everything else that's missing, though, are the angles. How are we going to find the angles? We got all the sides. Yeah, we're going to do a lot of those. This is applying what we just talked about. So if you think about it, that's what we just talked about. We're going to make the trig functions, and then we'll do the arc sine, arc tangent, arc cosine, whatever we need to do to find it. So we'll just start with angle A. You could do any function you wanted to here, any trig function. I would stay away if I because we found 6 square roots of 5. So here's kind of my rule of thumb. If I found the information and I can get by without using information I find, I try to go back to stuff they gave me, just because if you made a mistake finding that side, it's going to mess everything else up, right? So if you were on a test, that's kind of a good rule of thumb. That way your mistakes don't start turning into bigger other mistakes. So I'm just going to stick, just to be safe, with tangent, because I could not do the tangent of A. Don't I have the opposite and the adjacent side there? So let me do that. The tangent of A would be opposite over adjacent. It would be what? 6 over 12, right? That reduces to 1/2. It doesn't matter whether I reduce it or not. It looks like they're giving us things in degrees in this section, so let's make sure our calculator mode's in degrees. Since they're giving us in degrees, and we kind of like degrees better, we'll take advantage of being able to do it here. So you'd have to go you'd hit your second button, and then your tangent button, and then you type the ratio. I could type 1/2. I'm just going to type 6 divided by 12 just because I can. And I'm getting, let's see if we all get the same thing, or y'all getting about 26 point, we'll just go to 1 decimal place here. No, we'll go to 2. I see some of them going out to 2. That'd be about 26.57 degrees. Is that what y'all are getting? Okay. Let's see if I got it. All right, we go to angle B. Now we could do, let's see, opposite. We could do tangent of B also, couldn't we? If we just want to stick to the 6 and the 12, and you don't have to. I'm just like I always try not to make, if I make a mistake, I just don't want to get, I know when I was taking a test, I never wanted to make a mistake and then use that mistake to do something else. So I always try to be careful. We could do opposite over adjacent for B. We could say the tangent of B is, what, actually 12 over 6, isn't it? Just be so we could do that, arc tan, second tan. 12 divided by 6, which is just 2. You could put in 2 if you wanted to. Are y'all getting 63.43 degrees? Something like that when you round. What do you know about angle A and B? You know anything about their relationship to each other? Should they add up to anything specific, for instance?
90
Yeah, they should be complementary because they're in the right triangle. And if you look at that, they are, which that's a good sign, right? That they're adding up to 90 degrees. Angle C, well, do we need to do anything to solve for C? Isn't it just a right angle? It's a right triangle, so we don't have to do anything. We just say that's 90 degrees, and we've solved that triangle is kind of how they're looking at it. So if we look at number 3, for instance, you've got angle B is 71 degrees. And side B, the side across from it, is 14. They're still using that same drawing. So we'll go B, C, A. This will be little a, little c, little b. So if I look, if I know that this angle up here is 71 degrees, I know the side opposite is 14. You could do things in a lot of different orders here. First of all, your angles are easy. They want you to solve the whole triangle, so they want to know what angle A is and angle C is. C is always a right angle here, isn't it? You don't have to go, it's not like you got to go solve anything with that. What is A going to be? Do you have to do trig to find angle A? Nah, you could do trig, but it'd be like overkill, wouldn't it? Because isn't angle A going to be 90 minus 71? The acute angles on a right triangle are complementary. They add up to 90 degrees. So what would that be? 19, right? I can't subtract in my head. Okay, so now that we know these things, we might want to put them on the triangle. Well, we don't need the 90 degrees. We know that. Okay, so now we can start finding the sides. We know what B is, so we just really need to find A and C. If I could find A, I could use the Pythagorean theorem to find C, but you might want to do it another way. Now you got choices. You can use trig functions to find things. You can use the Pythagorean theorem to find things. You kind of just do what you're more comfortable with. Let's find A first. Let's see. If we're looking at this, we'll start with angle B here, okay? If I want to find side A, we'll say I'm trying to find that first. I've got the opposite side there, which is 14. I don't have the hypotenuse. I could find the hypotenuse now using trig, or I could find A. I'm going to start by finding A. Couldn't we do tangent? Wouldn't opposite over adjacent give me the tangent of that 71 degrees? Okay, so if I want to, I could say, okay, well, the tangent of 71 degrees is opposite, which is 14, over adjacent, which is A. And I could solve this. And if you remember how you can do this maybe a little easier, if you have a fraction on one side of an equal sign and just a term on the other, you can turn that into a proportion by sticking it over 1 and cross-multiplying. It's what proportions are so nice. They kind of sometimes save us a little time. 1 times 14 would be 14, and then A times tangent 71 degrees would be, if we cross-multiplied the other, side. If I want to get that A by itself, what could I do? Couldn't I divide out that tangent 71? Okay. Now you could do the calculate it before you divide, but I would tell you not to, because if I put this in my calculator, so that's going to cancel out. I can put this in my calculator and get a more accurate answer if I don't just round first and then use a rounded number. We're always trying not to round until the very end. So you do 14 divided by 10, 71. And y'all tell me if you get the same thing, because that way if one of our modes got off, I'm getting about 4.82. Is everybody getting that? Okay. Now, I don't know about y'all, but I kind of like that better than the Pythagorean theorem as far as finding a side, because it was faster. I didn't have to square and do so much subtracting and square rooting. So when I go to find my hypotenuse, I know now that A is 4.82. I could use the Pythagorean theorem, and you're welcome to do that if you want to. But you know what? These trig functions are turning out to be short little equations to solve, aren't they? We just use our calculator, or we don't have to do too much. So if I wanted to find C, maybe I say, well, Here's 71. Opposite would be 14, and the hypotenuse is C. Let's do the sine, because sine is opposite over hypotenuse. Sine 71 degrees would be the opposite side, which is 14, over the hypotenuse, which is C. And it's kind of like, I can just make a proportion and solve this so quickly that it makes me not like the Pythagorean theorem anymore. 1 times 14 is 14, and I get C times sine 71 degrees on the other side. If I want to solve for that, I'll make an answer box here. It would just be, wouldn't C just equal 14 divided by sine 71 degrees? If I divide both sides by sine 71. Okay, so we stick that in there. That was a whole lot better to me than using the Pythagorean theorem. A whole lot faster. It's about 14.81, and really I should have these little approximate signs here instead of equal signs. So I'll go change that because we did calculate those, and those are approximate values. Okay, in these you've got an isosceles triangle, and so they label it. Now, in an isosceles triangle, we know these two angles are equal. That's why they label them theta and theta. We know what that angle is here. It's 52 degrees. How am I going to use trig on an isosceles triangle? Anybody know? Got any ideas? How about I draw a perpendicular line down? In an isosceles triangle, if you draw the height in, it's a perpendicular line, and it bisects these two angles up here. If we knew that in the original triangle, before I drew the blue line, if this was 52 and 52, we could figure out what that angle was up at the top. 52 and 52 add up to 104, don't they? So if I subtract 104 from 180, since I know all the angles in a triangle are 180, I'm going to get 76. So this big angle was 76, but when I drew the altitude in an isosceles triangle, that halves that evenly. So that means each one of these is 34 degrees. And you know what? When I drew the altitude in, I created a right triangle, which is what I got to have if I want to use any trig. How can I know those 34 degrees are correct? There's a way I can check it here. Good thing we checked it, because what is 76 divided by 2? It is not 34. What is it? 38? Okay, it should have been 38. I'm like, it's a good thing we checked. Good thing I thought to, because you know what? 34 was wrong. Now do they add up to 90 degrees? We got two little right triangles. The angles in a right triangle have to add up to 90 degrees. There's another way you could have found those angles if you didn't realize that the isosceles bisects that top angle. Anyway, the two little angles are 38 degrees, not 34. 76 divided by 2 is 38, not 34. Okay, so now I've got my little right triangles. I can proceed. I might want to actually come off to the side. All they wanted here was the altitude. So let's see. I know this is 52. Let's write in what we know. We know that's 52. We know this is 38. And the B was 8 inches, but when you draw a line down an isosceles triangle, it bisects the angles up here. It also bisects the base. So this side's going to be 4. Could you find anything you wanted to now in this little triangle? You got 3 pieces of information, not just 2. We only need 2, and we got actually 3 pieces of information. And they want the altitude, so let me call that side A. I could do something like tangent of 52 degrees is the opposite, which would be, here's the 52, the opposite would be A. The adjacent side would be 4. Oh, look how easy this one is to solve. If I stick this over 1 to make a proportion, A times 1 is A. And on the other diagonal, when you multiply, it's 4 tangent 52. We can stick that straight in our calculator. It's even easier than some of the ones we had to solve above. Oops. 4 tangent 52. Somebody tell me what they got on that one. 5.12. If you round, it'd be about 5.12. There's your altitude.